Okay, so I'm putting the microphone on. Okay. So hi everybody, and before we're going to start, I want to understand from you how was the lecture and how you deal so far with everything that we have. So you can also Zoom people. You can share with us your thought and start. Yes, I'm here to hear whatever you have on your heart.
It was fine. It was a little calculus.
A lot of calculus, yeah.
But it was like at the end, like they started explaining the logic behind it, and then at the end it was just more calculus and how to.
Okay, nice. We're going to cover that. Also, we're going to go through it. So I talked to the people here in the class also, but in general, how we're going to deal with everything is going to be that you're going to have the lecture. After the lecture, you're going to have a session that you're going to complete on the video on YouTube. We're going to tell you specifically which videos to watch, which is going to sum up to 1 hour. Usually, it's going to be each section of the question going to be a short video, 10 minutes, 20 minutes, something like that, until it accumulates to 1 hour. And then we're going to have on Monday a live session. Today, it's actually, we're going to be doing that on Wednesday. It was not the plan, but you know, there was issues on Monday. So that's the reason we are meeting on Wednesday. And in general, you got everything you need in the tutorials. And on Monday, like this day, the live session, we're going to do extra stuff. I'm going to give you a question from exams, answer your question, give you a little bit focus about stuff that I know the students feel weak about. And beside that, some of you already joined me to the idea. I published a book on physics. This is the book, but it's only in Hebrew. So if you want to help me and join me to translate it to English, so the international will have it also. It's going to be a practice for you because it's going to be the same questions we're doing here. If you have background in Hebrew, of course. So you can talk to me and join this. This you contribute to the international. I also was an international student at the US, at Maryland. Was the best time of my life. I hope you had fun here in the day. So today I want to cover one question about charge. So let's dive into it. Do you know? Yes.
So in general, the live tutorial is going to be every time on Monday?
Yes, the live tutorial is going to be every time on Monday. Actually, I have the Hebrew class before your class. So I'm going to finish the Hebrew class, and then you're going to come in, and we're going to do our session. And then on the day after, you're going to have a lecture. And the day and all the rest of the week, you have the time to see the videos on your own time, the ready videos on the YouTube platform. And I encourage you to comment to the YouTube, and I'm going to answer you, to send me emails about questions. And also at the live session, if something was not clear, talk to me, okay?
But so we have to watch all the videos before Monday, and then?
Yes, I'm going to instruct you each week. I'm going to send a summary of what we did and also what I'm expecting you to do and finish until our next session. Okay? Perfect. And so the first thing I want to talk to you about, I talked to the student about it before, that this class is super cool. And why so? Because it's not a class, you know, at the beginning of you becoming a student and you don't have a clue about, you know, science and math at all. And it's not a really complicated class, you know, at the end of your degree. It's like something in the sweet spot in the middle. So we're going to deal with many phenomena from day to day, okay? For example, did you have this experience when you walk through the door and get a shock, electrical shock? You know this feeling? So the first question, we're going to deal with that. So if I have here my hand, this is my hand, okay? And during the day, you know, I accumulate feelings, like I'm angry about this guy, I'm happy about this guy, but also accumulate charge, especially in the winter, this phenomena happens. So I'm accumulating charge. So if this is my hand, okay, so in general, during the day, there's a chance that I'm gonna accumulate some charge on me. And if I'm gonna see a handle, let's draw a handle. Handle is a sphere, right? Some cylinder. And here I have kind of a box. Draw this box. Okay. This is a sphere, right? So when I'm gonna touch it, I have here some charge. The metal of the door are more friendly with this charge. The charge would like to go to this place. So when you're gonna touch it, all of the charge is gonna pass through the door. And this movement of charge is actually the pain. It's actually the heat that you're feeling immediately when you touch it. So the charge gonna distribute it around this object. In general, that's what happens. This is not painful. This is not painful. This is painful when it's moving away, okay? And I didn't talk to you about it, but let's do watching stuff beforehand. So this tutorial is actually after the video that you saw tutorial 1. I understand from the students here that you already saw tutorial 1. So this is something after tutorial 1 and after lecture 1, okay? This class today. Okay, continue. Just want to give this comment. So today we're going to talk about uniform charge density. Uniform charge density. And actually, this is the easiest charge density. Uniform means it's everywhere the same, okay? It's a constant function. In the tutorial, we deal with the really problematic charge distribution, right? But this is actually the simplest, the uniform. And why I want to emphasize and talk a little bit more about the easiest, because this is the most common thing you're gonna need. If I have charge and put it somewhere, probably it's gonna distribute it uniformly. It's the more simple case, and it's also really common in nature. In class, usually, and in exam, usually to avoid, hard math and stuff like this, they give you uniform. So I want to do one exercise about uniform and talk generally what is the method, how you're going to kill all the question in this subject, okay? So I want to approach this question. And what I'm going to give you, it's a given thing that the charge is distributed only on the surface of this doorknob. This is a doorknob. Let's do a look. This is the door, okay? Only around the surface of this weird shape of the handle, right? It's really weird. So only on the surface. So which kind of integralities? Not integral, sorry, charge density. We said, yes, we said that we have 3 kinds of charge density. The first one was linear charge density. We had surface charge density with sigma, and we have 3D row charge density, right? So usually this is the case, row. But if the problem is easy, you can get this one or this one, okay? Perfect. So how are you going to deal with uniform charge density? What's uniform said? It said that this is not a function of x, z, y, r. It's actually a constant. So let's examine what's going to happen. So I told you that this total charge that I have on my hand, okay, is equal to what? So remember from the tutorial? The whole equal to the sum of its part. So the whole equal to the sum. Sum is in math language integral. Its part, dq. dq is some division that I made to the charge. Okay? So this term is actually what it consists of 2 things. From the charge density, in our case, it's the surface charge density, and it's being multiplied by what? By area, right? Area units. Okay, why? Because these have units of charge, right? Coulombs per meter squared. So if I want charge, I want to cancel the meter squared, right? So surface is a meter squared. This one has units of meter 3, meter, and here is it 1/meter, right? So if I want to understand how much charge I have on every section of dA, what is dA? Let's draw it on the board. I'm going back to the handle. So if this is the handle, this is some dA, right? It's like a puzzle. This is dA, and this is dA, and this is dA. It's small parts that build the what? All this total surface, a total. It's the surface of all these doorknob, right? So this is what we said, this is constant. Remember? constant inside of integral. What I love doing to this constant? Take it out. Let's pull it out. So we have this integral. And what is this integral actually equal to? This said sum all the dAs that build the handle. So this is actually the surface of the handle. Okay, the surface of the handle is a little bit complicated, right? This is the hard part of this question, right? To understand what is this surface is. But this is the only challenge. So this build of what? Three things. The first thing is then the sphere. The sphere. So if I'm going to give you the this is L2, the radius of the sphere, what is the area of the sphere? It's equal to 4 pi L2 squared. That's the surface, okay? And then I need to sum it with another surface, the cylinder. What is the surface of the cylinder?
2 pi r.
Let's give you some intuition. Let's move the camera to this side. Just moving the camera.
It's good.
Yeah, but this one also. Wait. No, this is the zoom and this. No. Ta. Nice. Okay. So if this is a cylinder, how can I measure its area? Let's look at this. This is a cylinder. What I can do, I can cut it, right? I can cut it and open it. And then I'm going to have rectangular. So let's cut it here and let's open it, right? So this is actually L. Let's call it L and L1. This distance is the length of the cylinder, L1. Okay, so this stay L1, but this part, the red part.
Why do you have to open it? You can calculate.
I want to calculate what is the area of this cylinder, right? Because
then you do the area of the circle times the height.
Exactly. That's what I'm doing. I just want to show you this. Exactly what you said. I can say it more perfectly than you did. I want to cut it, and this one is 2 pi r, right? Let's call it r.
Okay.
R1. So the area of this thing is the area of the rectangular. 2 pi r1 multiplied by L1. Yes, you are correct. You saw what I wanted to do more explicitly. Okay. I'm going back to this board. Come on, you can do it, Easy camera. So the cylinder is over there, it's L1 multiplied 2 pi L1. And last but not least, we have this cube, right? So what is the area of the cube? It's actually each plane, right? The sum. So I need to give you also the dimension of this. So the dimension of this cube is actually not cube, it's a how you say it in English? It's not a cube, cuboid. Huh? Cuboid. Cuboid, yes, this is also good. Not exactly the word I look for, but you're right. So it's A, B, and C. And I want you to notice something. I have this, right? I have this one, which is AC, right? AC, but I have two of them. I have here and I have over there, right? Behind the cube. So I'll put here 2. And I have this thing, right? With the chart. This is BC. And it's also multiplied by 2 because I have it on the roof and also on the floor. And I have this thing around here, right? And this is BA, and also the one behind, you know, that detach the door that you don't see, actually have charge, right? So, exactly. So, plus 2AB.
Ron,
yes.
one question. Like, in the case of the cylinder, won't like the two circular faces be connected to the door?
Yes, exactly. So, you see this surface? I didn't count it, right? It's not up here. You're correct. But also, I am here, I agree with you, that here it's not perfect, right? I took some area from the cylinder, but I took also the assumption that this area is so small, so it's negligible. But you're definitely right. Your calculation will be better than mine, okay? So that's the idea. So in general, all of this thing is actually what equal to A total, right? Only this part. So we had Q total equal to sigma 0 multiplied by A total, which we just found. So sigma 0 equal to Q total divided by A total. We found it. Clear, right?
Yep.
Okay, so this is really common. You're gonna have this as many questions. They don't gonna tell you what is the charge density. I see it in exam all the time. They will not tell you, but they're gonna give you the dimensions, they're gonna give you the total charge, and you need to find out what is the charge density, because charge density tell you about forces, tell you about energy, tell you about all the stuff that physics want to know, okay? And I'm moving to this board.
Ron, just what is the little thing you draw up the uniform world?
The units,
No, uniform, when you wrote uniform?
uniform charge density.
Yeah, but up the wall.
That's the lock.
This is the lock of the door.
Ah, okay.
I'm drawing so bad.
Sorry. Okay.
Next time I'm gonna do a key, okay? Sorry.
Okay.
Okay, moving to this board. And to be wonderful if you can also, you're gonna be in charge of Zoom. Okay? So I'm gonna want to do a summary, because you know they can give you the linear charge density, the surface like we had today, and the volume, right? So let's do it in general. So in general, what is the method? How are you gonna solve that? So you have this Q total, right? The whole equal to, come on, continue with me. Sum of its part. Yeah, you got it, dude. Okay. And this one is equal to two things, right? First of all is the charge density. Charge density. Perfect. And this is going to be multiplied by some division unit, right?
Yeah.
It can be length, it can be area, it can be volume. Okay. And division unit. Division unit. This could be three things: linear, surface. And just repeat what we already said before. And this one, what is going to be? It's going to be or DL, you know, some line, or DA, area. Somebody can call it DS, surface. It's also common. This one. And the last thing going to be DV, right? It's going to be a DV. It's going to be, can be a cube, right? Some cube, right? See it correctly, okay? So this is all the option. But what we're going to do to this simple, uniform, constant, the word uniform. This is a constant, right? We can take them out. We're going to take them out. Let's call this UCD, uniform charge density. We're going to take out UCD outside. And in the integral, we're going to have the DU, division unit. DU, right? And this is going to be equal to Q total. So if you want to find this thing, this is going to sum up to what? To all the units, to all the things that we have, right? To the volume, to this is going to be or L, the length, or A, the area, or V, the volume. So in general, UCD, uniform charge density, equal to Q total divided by the whole thing. Division, the total, and how are we going to call it? Total object. Right? It could be some line, it could be some area, it could be some volume. Got it? So this is how you're going to find it. Okay? So this was the first question. Now I want to move to the second one. Okay, this was kind of a summary at the end. Yes, you have a, no. Yes, I'm gonna clean this board. You can move, both of you can move the camera. Thank you to our wonderful crew that came to the class and operate everything so good. So everybody at home, please send in some gift or something, because they're really nice to you and helping me. Applause, you're right.